Number 9, last problem. Read through it quickly. Object starts with a speed of 10 feet per second, speeds up at a constant rate. Okay, so there's an initial velocity. Constant acceleration, and a distance. The object then slows down to a stop at a constant rate over a distance of 121 feet. So hopefully this reminds you, we want to determine the total time traveled. Hopefully this reminds you of the problems where we had two parts, each part being constant acceleration. You don't have to draw it out, but it really helps to sort of make a quick sketch. We're given information about velocity and time, so we'll do a velocity time graph. We start at 10. Okay, we go constant acceleration, so velocity is getting faster. We don't know that velocity, but we do know the delta S here. Okay, object then slows down at a constant rate, so we know the velocity curve is going to be a straight line slowing down, so it's going to be a negative slope, and we know its distance, and it slows down to a stop. So the final velocity is going to be 0. So we know that one, and we know that delta S is 121. Okay, so you can get there in a couple ways. You can work with the constant acceleration equations, or you can work with the areas. Remember, area is delta S. Okay, and then we got a second area here. That's delta S. Okay. But to do that, we need to know this velocity. So if I know that velocity, I know the delta S's, I can figure out these two time parts. So let's do part 1 over here. I'll go ahead and do it in red since that's what we started mostly with. We know the delta S is equal to 94, which is equal to the area, which is equal to 1/2 10 plus V, so I'm going to label that V, times T1. Two unknowns, so I need to find V. So if I go to my other constant acceleration equation to use that value right there, we know V is equal to V0 plus AT. We don't know T either. Let's see, starts with speed, constant rate, 94 feet. So this equation right here still has two unknowns, so that's not going to help us out. Let's go to another constant acceleration equation. We have S equals S0 plus V0t plus 1/2 AT squared. Okay, we know delta S, so we know the difference between those two. We know our initial velocity, we know our A. So we can find time from this equation. I didn't see the right approach the first time, so I just wrote down some stuff, thought about what I knew, and then kept working till I found an equation that worked. So our delta S is going to be 94. That's S minus S0. Okay, is equal to V0 times T. So we have 10T plus 1/2 acceleration of 3 times T squared. I'm going to use a solver. I don't have a quadratic equation formula. So let's use the solver. Math 0. Okay, go back up, clear everything out. And we have to put it in terms of 0. So I'll use x for my variable and start right there. I have 0.5 times 3 x squared plus 10x and minus 94. Alright, I know the t is going to be positive, so I'll just make a guess of 10 seconds. Hit enter, and I get 5.256. T equals 5.256 seconds. Okay, that's part one. Part two. Okay, again, we know the delta S. We know our final velocity. We need to know some information about that initial velocity to work with that area. Okay, so let's go ahead and now calculate the initial, or the velocity there at the top of that thing is going to be our initial velocity plus 3 times our 5.256 seconds. Alright, so that's stored in x, so I can say x times 3 plus 10. So our velocity is 25.77 feet per second. Alright, so part two, our delta S is going to be the area. That's just a triangle, 1/2 our velocity 25.77 times this time right here, so we'll call it delta T2. Okay, and the area was 121. So solving for delta T2, I have my 25.7. Let's see, so let's just start with 25.77 was my previous answer. So I'm going to do 121 times 2 divided by my previous answer. And that gives me 9.39. Okay, so the total time equals our T1 plus delta T, and that's going to be the 9.39 plus our 5.256, 14.65. 14.647, so we can round that to 14.6, and that is seconds. Okay, we're done working the exam now. I would always encourage you at a minimum to scroll back through the exam really quickly, make sure your units and significant figures are right. I won't take the time to do that there, but that's always a good thing to do at the end of the exam. So let's finish up with that.